We're looking at factoring trinomials now to form ax squared plus bx plus c, and our goal is to go ahead and finish this up. We already practiced one of these. Our example in class was factoring this guy over here. We went through the following steps, and you should have got this as your factorization here. Moving onwards over here, if you look at page number 35, it starts out with this factorization here, and it asks us to really build this with algebra tiles. The goal over here is, as we move forward, we want to kind of get away from the algebra tiles. And so I'm going to model how we would do this factorization over here. We're not going to build this one with tiles. And so we're going to use the AC method. So we're going to multiply the A times the C, so A times C. So that's going to be 2 times 3. It's going to be 6. And so our t-chart is going to look like the following. We're going to have 6 here. And then it's going to have to add to the middle term. That's going to be 7. And then we need factors of 6. That's 6 times 1. 6 plus 1 is 7. And that's what I want. So then we write out our polynomial again. So it's 2x squared plus blank plus my last term, which is 3. What goes in the blanks? The two things that add to 7, which is 6 and 1. And they both need an x. We use factoring by grouping. So the first group here has 2x in common. The second group here has nothing in common. Notice they don't have anything in common, right? So you can always put a 1. You can think of them as having 1 in common. Every factor, 1 is a factor of everything. And note what's left over is just x plus 3. Double checking, 2x times x is 2x squared, 2x times 3 is 6x. Next, we pull out the x plus 3, because that's common to both of these. So I get x plus 3 times 2x plus 1 here, which is what we have at the bottom and at the top. Next one over here, we did this one in class, so we may skip. Practicing again, I think this was done in the front. So we do not need to do that one again. You see it's that same problem. And again, we've already done this one. We already talked about this problem here. So notice over here, when you we're looking at right now the classwork on page number 40. If we have the following problem, I have 6 minus 7x minus 5x squared. What you have to do with this one is you first need to get it into standard form. So you have to make it look like ax squared plus bx plus c. So what we do is we rearrange it. So I put the negative 5x squared here, minus 7x, and then plus 6. I do the AC method here. So negative 5 times 6 is going to be, what is that? That's going to be negative 30. And then we put negative 7 in here. And then we say, what multiplies to give me negative 30? That has to add to negative 7. So what is that? That's going to be, what is that? 6 times 5, negative. Negative 6 plus 5 is negative 1. That's not what we want. 6 times negative 5. 6 plus negative 5 is 1. That's not what we want. Let's try 15 times 2, negative. Negative 15 plus 2 is negative 13. That's not what we want. What else can we try? How about 15 times negative 2? What is that going to be? When we add them. So 15 plus negative 2, that's 13. That's also not what we want. So maybe we have a problem here, do we? How come we're not getting what we need? What other factors of 30 are there? Are we missing any? So what does this mean for this problem? Interesting. Am I missing something? What other factors of 30 are there? This problem doesn't seem to be working out. Here, extra credit, find my mistake. What am I missing here? What factors go here? I can make this work. That should all be all the factors of 30. Let's make sure to write them down, right? Yeah, right? That's it. Oh, I remember now. No extra credit. Figured it out. 3 times 10 is 30, and this one needs to be negative. And then 3 plus negative 10 is negative 7. There we go. That's the one we needed. So then, sorry about that. And as you can see, everybody makes mistakes. So now what goes in here, so it was going to be 3 and negative 10. Actually, really should have just used this chart here, right? So what are we saying? So we need 3 and negative 10, and if you add them, 3 plus negative 10, that gives me negative 7, which is what I wanted. And then we go ahead and factor by grouping. So down here we should get negative 5x squared plus 3x plus negative 10x plus 6. We will, plus and minus is just minus. That's 5x squared plus 3x minus 10x plus 6. The first two have x in common, so we get 5x plus 3. The second two, I'm going to take out a negative 2, so I get 5x minus 3 over here, and something is amiss. If we notice, we have a problem now because these are not the same, and they're not off by negatives, so that means, oh, here we go. This is the problem. This is negative here. I dropped a negative. So then this is, we should have taken out, so this is negative, and now they are off by negative. So I'm going to pull out a negative from this one here. So I'm going to get x times negative 5x plus 3 minus 2 times negative 1 times negative 5x plus 3. Excuse me. And onto the back side, what we get then is we had x times negative 5x plus 3 minus 2 times negative 1 times negative 5x plus 3. And then negative 2 times negative 1 is 2. Positive. It's just positive 2. Now they have the same thing. We take it out. We're going to factor it out. And we get x plus 2. It's just the factorization we wanted. Okay? And as you can see, this just continues to repeat itself over and over again in the same way, even with these more complex problems here. So if you have this one here, it's the same thing. You multiply a times c, which is 12. So factors of 12 are what? 4 times 3. 4 plus 3 is 7. We want 13, right? Because the middle term is 13. What else? 6 times 2. 6 plus 2 is 8. That's not what we want. What else is there? Factors of 12. 12 times 1. 12 plus 1, lo and behold, is 13. So it's going to be 12 and 1. That means in our blank spaces it's 12 and 1. So when we factor by grouping, we would get the following. So we're going to get 12 and 1 here. So then we're going to pull out what they have in common. They have a 2y in common. And then here they have just an x in common. So if I pull out 2y, I get y plus 6x. And I get here y plus 6x again. And what else do they have in common here? They have these in common. So when I pull it out, I get y plus 6x times 2y plus x. And that is my factorization here, which is what I wanted. Okay, and this continues onwards. Okay, so what you guys should do, you should do this one by yourself. There are some special ones, factorizations that we need to make note of. The difference of squares one. So if you see difference of squares, it's basically a square minus a square. And so you have x squared. So just something to remember. If you have x minus 2 times x plus 2, if we were to multiply this out, we get x squared plus 2x minus 2x minus 4 the middle terms cancel out, and I get x squared minus 4. This means that x squared minus 4 is x minus 2 times x plus 2. This works for all of them. And this is called difference of two squares, or perfect squares here. So note, if you have a sum, it doesn't factor. This does not factor. So in the same sense here, difference of squares. So this one is going to be as this is essentially 2x squared minus 3 squared. So then, when you factor it out, you put 2x minus 3 times 2x plus 3. And that tells you what the factorization is. So this here is going to be 2x minus 3 times 2x plus 3. In general, difference of squares is a plus b times a minus b. The next page over here, we'll probably do in class if we have time. And I think that's good for now.